Alright, third and final technique we're going to talk about for solving quadratic equations. Got old faithful formula. Any of you probably quadratic formula, so look at it. If we have a quadratic equation, important part to remember here, we got to have everything on one side, got to have it equal to 0, just like we're going to factor. And then we need the terms in order, so a is the coefficient of the x squared term, b is the coefficient of the x term, c is our constant term, the term with the x's. And then we say a is not equal to 0, that just means we have a quadratic equation. A is equal to 0, it's a different type of equation. Later. Have all that, then we have a formula that says to find our solutions, our x values, it's negative b plus or minus the squared b squared is 4ac. And then that whole monster is divided by 2 times a. So let's look at an example. Okay, good thing about the quadratic formula is it always works. You can use it on any quadratic equation, unlike factoring. The bad news is that we usually end up having to do a lot of simplification. Okay? So to me, if you can factor, factoring's better. If you're comfortable with completing the square can be better in a lot of situations. And usually my last choice is quadratic formula because you end up writing so much down. I know a lot of you will prefer quadratic always, but it works and I understand that. To me, especially, I factor if I can factor and then think about it. Okay. So we have a quadratic equation here. Our a, 3, not the x squared, just the 3. B is negative 5, not the x, just the negative 5. And C is negative 1. Plug into our, tells us our x's. We get when we take the opposite b. Already have double negative signs there to deal with. Plus and minus square root of b squared. Be very careful here. Use parentheses because we do negative 5 squared. It's going to give us a positive number. It's 4 times a, which is 3, c, which is negative 1. This whole thing divided by 2 times a, so 2 times 3. Now we have our solution, but we need to simplify. We have a lot of simplifying to do here. First of all, let's get rid of our double negative sign. Negative is positive. Then we have negative 5 squared, which is positive 25. We have negative 4 times 3 is negative 12. Times negative 1 is positive 12, so plus 12. The whole thing is divided by 6. Simplify under the radical. 5 plus 12 is 37. If we can simplify square root of 37, we need to. In this case, that will not simplify anymore. Two solutions here are what we get when we do 5 plus the square root of 37 divided by 6. We get when we do 5 minus the square root of 37. That answer divided. Okay. Another way you can write this is you could split it up into two fractions. 5 over 6 plus and minus square root of 37. Equivalent way to write the two solutions. And again, we do have two solutions. Okay. Let's get another one. Kind of want to get all the scenarios down here. So now that one we got an irrational solution because we had square root of 37 in there. So you could get a decimal approximation by putting it in your calculator, but that's the exact solution has that square root of negative 37 in it. Another one, 4x squared plus 12x 0. Here, c is positive 9, so at least we don't have any negatives in there. So x is going to be the opposite of b, so negative 12 plus and minus square root of b squared, so 12 squared, minus 4 from the formula times a, which is also 4, times c, which is all divided by 2 times. Okay, now we need to simplify. Thing here, I'm going to start underneath the radical. 12 squared is 1. We do negative 4 times 9, with negative 1. Bottom 2 times 4. Negative 12 plus or minus, if we take the square root of 0, that's just 0. Plus or minus 0, we need that. 8. Simplify. Take a common factor of 2 out of the top. 4, we got another common factor of 2. On this one, we only get one solution. That in my solution. Squared 2x 2 0. A this time is 1. B 2. C also 2. X plus or minus opposite of b, sorry, negative 2. B squared, so 2 squared is 4 times a, c 2. All of that divided by so start simplifying. Meet the radical. Squared is 4. Then we have negative 4 times 1, negative 4. 2 is 8. 2. So negative 2 plus or minus of 4, 2. So now notice we have a negative underneath the radical. What we call our solutions here depends on what the problem told us at the beginning. If it said find all real solutions, we're not going to have any, because what's the square root of negative 4? We don't have a real number solution. We could call that 2i. So if it told us to find all real numbers, we have none. So no real solution. If it just said find all solutions, we do have some complex solutions. So simplify. Taking out an I, square root 2. Square root of 4 is 2. Negative 2 plus or minus 2 times that 2. And this was the case, it would say put it in a plus bi form, so we would have to split it up into fractions. 2 over 2 plus or minus 2i over 2. And by these fractions, so negative 2 over 2 is plus or minus 2 over 2 is just two complex solutions. Negative 1 plus I, negative minus I. So if it asked for real solutions, we would say no real solutions. It said find all solutions. Negative 1 plus I, negative 1 minus I. It's BI form. So we've had 3 scenarios here. We ended up with some irrational solutions, 2 of them. Had only 1 solution time, and we've had 2 complex solutions, no real solution. And without working the problem all the way out, we could figure out what type of solutions we're going to have just by looking at part of the quadratic formula, discriminant. And the discriminant is the part that's underneath square root. So the discriminant is the b squared is 4ac part of our quadratic. So the way we tell what type of solutions we're going to have is if our discriminant, and I'm just going to call it capital D, if our discriminant turns out positive, so bigger than 0, we're going to have 2 real solutions, plus or minus 2 solutions. It's positive, both real. Like our first, even though they were irrational. Example. Our discriminant turns out to be exactly equal to 0. This is like our second example. So then the plus or minus square root part goes away. Plus or minus 0 doesn't change anything. So we only have real number solution. Working great there. And then the other possibility is that our discriminant is negative, less than 0. In that case, we're going to have no real solution. Let's write that down. Discriminant is negative, we have no real solution. But we will have 2 complex solutions. Make sure you're paying attention to the directions. If it says find all real number solutions, you get complex numbers, and you're going to say none. If it just says find all solutions, you get complex numbers. Type those in. Okay, so that is the final part of solving quadratic.